Greeting of the day and welcome to the video. In this video lecture, we are going to deal with the numericals which are based on Henry's law. What is Henry's law? How Henry's law is used up for the different types of numericals which are asked in the CBSE examination. So to remove that phobia, we'll be having a thorough practice of the numericals based on Henry's law. So have a proper practice, students. Till you do not practice the numericals, it will be difficult for you. So get ready and get started. In numerical based on Henry's law, we'll be dealing with different numericals and don't have the phobia of numerical. It's very easy and simplified. See the steps, go with the steps, and twice and thrice when you solve the numerical, you'll be in position to have the confidence in you and you'll be able to solve. So let's begin with the first numerical. H2S, a toxic gas with rotten X-like smell, is used for the qualitative analysis. If the solubility of H2S in water at STP is 0.195 m, calculate Henry's law. So for that, molality is 0.195 m, which is provided to us. So 0.195 moles of H2S dissolved in 1000 grams of solvent water. So XH2S is equal to 0.195 upon 0.195 plus 55.55, which is equal to 0.195 upon 55.745. Now P is equal to KH into X, that is known to us. So 1.013 into 10 to the power minus 5 Pascal is equal to KH into 0.195 upon 55.745, which we have calculated in the previous step. So when we simplify it, take this right hand side 0.195 upon 55.745 to the other side, KH becomes equal to 2.89 into 10 to the power 7 Pascal, which is the desired answer for this numerical on the simplification of this relation which we have taken prior to this. Second numerical is Henry's law constant for CO2 in water is 1.67 into 10 to the power 8 Pascal at 298 Kelvin. Calculate the quantity of CO2 in 500 ml of soda water when packed under 2.5 atmosphere of CO2 pressure at 298 Kelvin. So for that, KH is equal to 1.67 into 10 to the power 8 Pascal, which is given to us. Pressure of CO2, P CO2 is 2.5 atmosphere, which is equal to 2.5 into 10 to the power 101325 Pascal. Conversion. Applying Henry's law, the pressure of CO2 is KH into XCO2. So XCO2 is pressure of CO2 upon KH, that is 2.5 into 101325 Pascal upon 1.67 into 10 to the power 8 Pascal, which is equal to 1.5 1.517 into 10 to the power minus 3, or written as 1.152 into 10 to the power minus 3, whatever way you want to go for. Therefore, NCO2 upon NCO2 plus NH2O is equivalent to NCO2 upon NH2O, because in the denominator, since value of CO2, NCO2 is very less, so as compared to NH2O, so that is neglected. So that becomes equal to 1.517 into 10 to the power minus 3. For 500 ml of soda water, water present is 500 ml, which is equal to 500 grams if we calculate, because density is 1. So 500 upon 18, that is a molar mass of water. So that becomes equal to 27.78 moles. That is NH2O is 27.78 moles. Now NCO2 upon 27.78, which is NH2O, that is equal to 1.517 into 10 to the power minus 3, or when we simplify, we multiply 27.78 into 1.517, so that becomes equal to 42.14. So NCO2 becomes equal to 42.14 into 10 to the power minus 3 moles, which is equal to 42.14 mole, or simplification gives 42.14 into 10 to the power minus 3 into 44 grams, that is molar mass of CO2. So on multiplication it becomes 1.854 grams, which is the desired answer. Coming to the third numerical, the partial pressure of ethane over a solution containing 6.56 into 10 to the power minus 3 grams of ethane is 1 bar. The solution contains 5 into 10 to the power minus 2 grams pressure of ethane. Then what shall be the partial pressure of gas? So according to Henry's law, M is directly proportional to P, or we can say M is equal to KH into P. Thus 6.56 into 10 to the power minus 3 is equal to KH into 1. Pressure is equal to 1 bar, and 500 into 10 to the power minus 2 is equal to KH into P. Now comparing the equation, so 6.56 into 10 to the power minus 3 upon 5 into 10 to the power minus 2 is equal to KH into 1 upon KH into P. Now simplifying it, so taking P to the left hand side, so the reciprocal of the other component will take place, that is 6.56 into 10 to the power minus 3, which is in numerator, will come into denominator, and 5 into 10 to the power minus 2 is in denominator on left hand side. On right hand side it will become the numerator. So P is equal to 1 into 50 into 10 to the power minus 2 upon 6.56 into 10 to the power minus 3, which on simplification and all the calculations become equal to 7.62 bar. So that is the desired answer. 6 numerical says Henry's law constant for the molarity of methane in benzene is 298 Kelvin, is 4.27 into 10 to the power 5 millimeter of Hg pressure. Calculate the solubility of methane in benzene at 298 Kelvin under 760 mm of Hg. So according to Henry's law, P is equal to KH into X. X is equal to 760 mm of Hg upon 4.27 into 10 to the power 5 millimeter of Hg pressure. Now X is equal to 760 into 10 to the power minus 5 upon 4.27. When we simplify it, we divide 760 by 4.27, it becomes 178 into 10 to the power minus 5. So this was the answer to it. Coming to the fifth numerical, the Henry's constant for oxygen dissolved in water is 4.34 into 10 to the power 4 atmosphere at 25 degrees Celsius. If the partial pressure of oxygen in air is 0.2 atmosphere, calculate the concentration of O2 in air. So again the same thing we are doing, students. Whatever is given to us we are writing and substituting the value so that we get the answer in a shorter duration of time. So the pressure of oxygen is equal to KH into XO2. Again I repeat, pressure of O2 is equal to KH into XO2. Value of PO2 is 0.2. KH is 4.34 into 10 to the power 4. XO2 we have to calculate. So the relation becomes 0.2 is equal to 4.34 into 10 to the power 4 into XO2, or XO2 is 4.6 into 10 to the power minus 6, or XO2 is equal to NO2 upon NO2 plus NH2O, or XO2 is NO2 upon NH2O. So substituting the value, 4.6 into 10 to the power minus 6 is equal to NO2 upon 1000 upon 18 mass of water, which is equal to, on simplification, NO2 becomes equal to 2.55 into 10 to the power minus 4 moles per liter, which is basically the desired answer. So here students, we have dealt with only the numericals of Henry's law, and these numericals have their own importance in the competitive examination as well as in the CBSE and MP board examinations. So have a proper practice of numericals. Don't have phobia. If you are not able to understand numericals, at least require 2 to 3 efforts. Try it again. Practice makes everybody perfect. So you'll be able to solve it with this concept. So thanks a lot for studying numericals of Henry's law with this video, and take care of yourself. Have a good revision of it. Have a good practice, and thanks a lot. Before we come with the question and answer session.